Hi everybody. I'm disappointed we couldn't all be there in person today, simply because I've spent a lot of quality time down in South Africa over the years, and indeed it was quite a formative experience that got me working down there, that got me working in agriculture in the first place. But nonetheless, we will proceed, and I will hopefully be able to tell you a few interesting things about the world of agriculture and some of the technology that is trying to remake that world. So I'm just going to start by giving you a brief introduction of what agriculture is, what the big problems in agriculture are, the pathways towards solving some of those problems, and then finally some of the cool technologies that we're using to help us along the way. I always like to start all of my talks by explaining to people that there is nothing natural about agriculture. It is an artificial food chain built by humans for humans, and there's nothing natural about it whatsoever. I think it's just because it evolved over such a long period of time that we view agricultural production as being somehow natural. And this current method of food production that we have today, which is known as Green Revolution agriculture, it's been incredibly successful in feeding the world and helping us get to the 7.6 odd billion population that we have today. However, it's not without its problems, and we need to feed 10 billion people by 2050, which will require approximately 70% more food than we currently produce today. So our single biggest problem in agriculture is the amount of land we use to do it. Food production uses dramatically more land than anything else we do as humans. And indeed, this is also true in South Africa. In South Africa, 79% of the land is used for agriculture, 10% of that is arable land, and 70% of it is, 60% of it is pasture land. That fits fairly well with the global paradigm, where the vast majority of land we use for agriculture is in fact pasture used by ruminants like sheep and cows, and then the arable land is used for crop production. And 43% of the crops we produce in our arable land actually gets used as animal feed. And that's the principal reason you hear a lot of people talking about the larger environmental impact of animal-based foods versus plant-based foods. Now, the second biggest problem we probably have in agriculture is how much emissions come from it. After energy production, emissions is probably our second biggest problem that we have in agriculture. And most of those emissions come from our livestock sector, principally beef cows, largely from their enteric fermentation, which all ruminants do, and it's most readily translated as cow burps. And then also from the manure that we have coming from cows that we also get a lot of savings from by using that as fertilizer. However, as with everything in agriculture, it's not quite that simple. While cows are our largest source of emissions, our second largest source is in fact rice, due to the amount of methane produced from the anaerobic rice paddies that we have. That being said, we are making a lot of headway with our agricultural emissions. There's feed additives for cows that can reduce their methane emissions by up to 30%. We have anaerobic digesters that produce energy from our manure, while also making the manure less polluting when we use it as a fertilizer. And we're also starting to modify some of our crops to make them less environmentally harmful. But as I said, agriculture is complicated. And while livestock are the principal cause of our problems with emissions, how we produce broadacre tillage, which is 90% of our arable land use, is the principal cause of our biodiversity loss. And the reason we lose so much biodiversity to broadacre tillage is because of the amount of pesticides, herbicides, fungicides, and nitrogen, phosphorus, and potassium-based fertilizers we use. So a good way of looking at agriculture is any agricultural use of land is bad and worse than just leaving it alone. However, pasture-based agriculture tends to produce more emissions, but is less harmful to biodiversity, whereas broadacre monocrops tend to have dramatically lower emissions than livestock agriculture, but they also have a far worse impact on biodiversity. So in order to solve these problems, we need to find systems and technologies that help mitigate the worst excesses of both kinds of agriculture that we have. And again, the three big problems I've already identified, it's bearing in mind that
each different agricultural production system and each different agricultural crop, be it livestock or plant, negatively impacts the environment in different ways. So there is no one size fits all for all of these problems.
And the next big problem that we need to solve in agriculture is waste. The slide here is presenting waste that kind of happens after farm level. Farm level waste we can deal with quite well because we tend to recycle it back and feed it to cows.
And that's something that often goes unrecognized. Cows are, in fact, one of the biggest recycling things that we use on the entire planet in any sector. However, we still waste a lot of food after the farm gate. And if we can reduce that waste to zero, that dramatically reduces how much more food we need to produce by 2050. Now, these stats don't include other large waste sources, such as obesity is a serious waste of calorific resources that we probably need to have a bit more of a serious conversation about at some point on a human cultural level. Additionally, with exponential human population comes exponential human poop. And we really need to get a way of taking, as I said, we have a food chain, and taking what comes out the bottom of that chain, i.e. human feces, and getting those nutrients recycled back to the farm. That's one of the single biggest problems we need to solve in global ag today.
We talk a lot about sustainability in agriculture, and indeed a lot of what we're doing in ag now is about improving the sustainability of a food system that is already capable of feeding the world. So when I try and think of sustainability, I think something is not sustainable unless it's economically sustainable, environmentally sustainable, and socially sustainable. And all of these things are interlinked, but they're also quite complicated and hard to get agreement with everyone about what sustainability actually is. So by economic sustainability, the farmer needs to make enough money to live a good life, and the food needs to be cheap enough that people can afford to buy it. With environmental sustainability, are you talking about emissions, biodiversity, pollution? Which one is more important? Which one do we need to focus on?
Finally, social sustainability is arguably the most difficult one because each different culture has a different idea of what is socially sustainable or otherwise. And again, referencing back to South Africa, I've had lots of South Africans over the years explain to me how smallholder farming is going to be really important for the future of South Africa on a social level. And I always respond to that and say, yeah, that's totally fine. If you want that, you can have that. But bearing in mind that smallholder farms inherently increase the cost of food production because you're adding the cost of that family's life on top of the cost of food. And there's major economies of scale from having less people producing more food. So you can have lots of smallholder farming on the understanding that your general food is going to be more expensive, and the people who get hit hardest by that are the most vulnerable people in the economy.
So, we can have a completely environmentally sustainable agricultural system today, but it's going to cost a fortune. And as one of my customers likes to say, it's hard to be green when you're in the red. Now, we also need to bear in mind that traditional agriculture is improving rapidly. In the United States, for example, they have half the amount of cows producing twice the amount of milk. Since the Green Revolution came in, we have dramatically more cereal yields and general crop yields, while barely increasing our use of land over the last 50 or 60 years. And I don't think it gets fully recognized in the general media just how amazing agriculture has increased its productivity. However, that increased productivity hasn't touched everywhere. There's an uneven distribution of best practices that gives our maximum agricultural intensification. And normalizing agricultural best practices and intensification can give us dramatically good upside. And a lot of technologies in agriculture, including what my own company does, is focused on doing that. The example I'm giving in the slide here, there are 275 million cows globally producing 2,400 liters of milk per animal per year. The average US cow, and in other territories too, produce 10,500 liters of milk per animal per year. If all cows in the world produced at the efficiency of a US animal, we would only need 69 million cows rather than the 275 million cows that we have providing today's milk. And the amount of environmental and economic savings from taking 210 million cows off the planet is just insane, all while not losing a drop of milk. If we can increase global average dairy yields to 15,000 litres per animal per year, we would need only 60 million animals to feed 10 billion people at today's level of consumption. And that is an astronomically tangible goal for us to reach for. And it's again very similar situation on crops. If you pick any general crop, you will often find that 20% of the producers are producing 80% of the food, and the 80% of the producers producing the other 20% in lower yield environments are the people who are causing most of the environmental harm.
So simply mapping best practices and not permitting people who are producing with low yields to produce like that can give us dramatically more food using dramatically less land with not a lot of technology being applied to that. And my own company, Cainthus, that's kind of one of the things we're trying to do with dairy.
We use computer vision to monitor all the cows in large-scale dairies in order to enable farmers to produce more food using less inputs and less labor. And we like to think at a certain point in the future that we'll be able to give our tools to a farmer anywhere in the world, and that will enable that farmer to produce dairy produce at the same level of efficiency as the best dairy farmer in North America or anywhere else in the world. And one little shout out for something I'm very proud about in this current version of the product. If you look at the screenshot, you can see a cow comfort index. We're the first company in the world that have quantified and report in real time how comfortable or otherwise all the animals in a given facility are. And we'd like to think that will help a lot with consumer understanding of animal welfare and how that interacts with productivity and sustainability. Now, getting back to the crop side of things and preparing to show you some really cool other technologies, back in the 1960s, before the Green Revolution, we had a low productivity production system that was really environmentally friendly because we didn't use a lot of chemical inputs. Today, we have an extremely high productive crop production system, but it systematically degrades the environment in which you produce those foods simply because of the amount of pesticides, herbicides, and fertilizers we're using to produce that food. So in many ways, simple intensification isn't going to be enough to stop a lot of environmental harm. We also need to work out ways to farm in a more ecologically sustainable fashion that uses dramatically less chemical inputs. And fortunately, we have lots of ways of doing that today. We've lots of farming methods like polycropping and things like that that can produce extremely large yields while having dramatically lower environmental impact. However, the labor costs of producing like that are astronomical. And this is where all these cool new technologies come in. So the slides you're looking at here are our latest and greatest agricultural robots. And these robots are going to enable us to farm on a plant-by-plant basis where we're growing plants together based on symbiotic benefits, enabling us to maximize our production, while, as I said, having dramatically lower ecological impact. The world's first hectare has already been farmed completely autonomously, the Hands-Free Hectare project in Harper Adams in the UK.
Successfully grew a hectare of cereals without a single human ever touching it. It was all remote sensing, robots, and autonomous intervention. So these robots here in the slide, these show seeders, weeders, harvesters, and eye-in-the-sky drones, all of which will enable us to manage on a plant-by-plant basis, enabling us to produce higher yields than our best production systems can today with a fraction of the chemical inputs and a fraction of the environmental impact.
And another new technology that has me very excited is insects. South Africa actually has one of the largest insect companies in the world, a company called AgriProtein. And then we've also got Protix Biosystems in the Netherlands and Y-Insect in France. And insects are fascinating because they can do a lot to close the waste loop in global agriculture. So waste is a human invention. In natural systems, there is no waste, but we have lots of it now, chiefly due to our cities.
And the reason insects are so important is because we can feed them food waste without having too much risk of contaminants or anything like that. And we can also potentially feed them raw human feces, which, as I said, hopefully gets rid of that food chain to food loop problem I discussed earlier. The other great thing about insects is while we currently feed corn and soy and 43% of our arable land to mostly pigs, chickens, and fish, insects actually make a better food source for those animals. So for us to recycle human waste streams, feed those streams to insects, and then feed those insects to livestock, that's potentially a much more efficient food loop than how we currently produce things.
And there may be someday that humans even decide to start eating insects themselves. As I like to say, when you have arthropods in the sea, they're considered a delicacy and you command a price premium for them. You put arthropods on land and they're considered disgusting. I hope eating insects gets a lot more normalized in the Western world, certainly. I've actually eaten insects down in South Africa, so I know that's somewhat acceptable down here. Another new tech area that we need to accelerate a lot faster is aquaculture. So we first started doing commercial scale aquaculture around 100 years ago, and that area is developing rapidly at the moment. The slide here is basically demonstrating that we've learned from a lot of mistakes on land, and we're already starting to build multi-trophic aquaculture production systems where we're mixing fish production with kelp production with bivalve production in order to make a closed loop feed production system that neither pollutes the external area or requires a major additional feed inputs beyond what you're already growing in the aquaculture facility. And aquaculture is incredibly important for three reasons. One, 70% of our land is salt water. Two, you don't need to use fresh water to grow things in salt water. And three, due to the buoyancy effect, feed conversion ratios for fish tends to be much better than what we can achieve with things like pigs and cows. Now, moving on to some things that are a bit further removed from traditional agriculture, there's a general technological trend where we're attempting to replace old agricultural tools and systems with new versions that have dramatically lower environmental footprint. So if you look at the companies I have listed here on the right, Indigo were a company that make microbial-based fertilizers, replacing nitrogen, phosphorus, and potassium Haber-Bosch style fertilizers. We have Ubiome, who are making biopesticides, again, where we're using natural things to control our pests rather than general spray and pray, kill everything pesticide applications. Harp are a company that are doing bioherbicides that can potentially replace Roundup, so we can keep our weeds under control while not poisoning the ambient environment in the process of doing so. Sustainable bioproducts are really interesting. They took a yeast that they found in Yellowstone Park, they're feeding it sugars, and that's outputting a protein that can be edible by humans or by livestock. Solar Foods take it a little bit further. They're taking carbon and nitrogen directly from the air and synthesizing that into a protein that fits the nutritional profile of soybean, which again can be both edible by humans and livestock. However, these last two have the same issues as the next interesting thing I'm going to talk about, which is cell-based meat. Mosa Meat and Mark Post, pictured here, were the first company in the world to make a cell-based or biofermented burger that was grown out of the fat and muscle cells from a cow. Again, this is tremendously exciting on a long-term perspective that we may be able to produce meat without ever involving animals whatsoever. However, the problem is the same as with sustainable bioproducts or solar foods. You need a feedstock for these things. The earlier ones were made with fetal bovine serum, which is basically embryonic fluid from dead cows. Now they're using corn-based glucose, so sugars. But
corn to corn glucose to burger is probably less resource efficient than simply feeding cellulose to cows and getting burger. So that's a challenge they need to overcome, making it more efficient than today's production systems. The second thing is we don't produce cows or chickens for burgers and chicken nuggets. They're byproducts. Cows are produced for steak. So if you want to take cows off the planet with substitutes, you need to be substituting whole steaks. If the whole world ate veggie burgers or cell-based burgers, that wouldn't take a single cow off the planet, because that's not why cows are on the planet. So that's a problem that needs to be surmounted. They need to be making whole foods.
Another technology that gets a lot of attention is vertical farms. Vertical farms are very interesting from a food security and food safety perspective. From a food efficiency basis, they're actually quite inefficient today. That can change over time. But as I mentioned earlier, our broadacre tillage crops are 90% of our global arable acreage. So vertical farms only get really interesting if we can do something like grow only the heads of grain in the vertical farm, because currently none of those broadacre tillage crops can be grown in a vertical farming hydroponic environment.
However, technology like CRISPR can change that. So CRISPR is the gene editing technology that there's a lot of excitement about what you can do with human health with that. But with respect to crops, so when the Green Revolution happened, the heads of grain were too big, and we had to use hybrid crops to enable the grain to take the additional nitrogen we were putting in without damaging the crop. Vertical farms are in a similar scenario. If we can use CRISPR to remove all of like a wheat plant except for the head of wheat, and that grows a giant head of wheat grows in your vertical farm, well, then vertical farming can become very exciting beyond just food security and food safety situations. Because if you can grow broadacre arable field crops in vertical farms, well, that's when that technology gets truly exciting.
Now, CRISPR is very exciting for crops because we can do things like increase drought tolerance and increase salinity. And the slide here is from a company called Pairwise that are seeking to do exactly those type of things with crops. But CRISPR is also applicable to livestock. There's already hornless cows that have been bred using CRISPR. So we'll hopefully see CRISPR applied to livestock to also reduce their environmental footprint. Now, just to finish up, I'd like to just make a few points about sustainability and where we are with that today. Because there's a lot of doom and gloom, not just in agriculture, but in the general populace about the direction we're heading in terms of biodiversity and sustainability and everything. And anytime I feel down about that, I always like to think about these two images in this slide. If this was a live audience, I'd ask you to guess where these two places are. The image on the left is from Chernobyl. And Chernobyl now has Europe's highest amount of biodiversity and Europe's highest level of biomass. The slide on the right is from Bikini Atoll, where the United States famously did a lot of their nuclear testing back in the 1950s. Bikini Atoll exclusion area now has more coral, richer biodiversity, and more biomass than the areas immediately surrounding the occlusion zone.
One can be misanthropic and say this gives us a perfect test control proof that human civilization is actually worse for the environment than nuclear fallout. And that's certainly one way to interpret it. But I like to interpret it a bit more positively. And that is, we exist in a rare situation today where the future of our food system is not predicated upon providing enough food to feed all of us. We already have more than enough food to feed us. The food productions as they exist today can feed 10 billion people by 2050. The question and the choice we need to make today is what happens to our planet in the act of doing that.
And I hope with all the wonderful technologies you've seen today and all of the pathways that we have ahead of us, that you'll reach the same conclusion that I have, which is that we have a wonderful natural future ahead of us if we make the correct choices today. So thank you very much.